Somebody have the mean for me.
5, how did you figure that out? Add them all up and divide by 6. So how much was it? 30. And you divide it by 6. And you got 5. And we learned the other day, right, that if I can manipulate these, balance them out, and balance out the mean. So this is already 5. This one's fine.
You take 4 out of 9.
Take 1 off of that one. Add it to this one.
You take 4.
I can take 4 off of this one.
And then add 1.
And add 3 to 2. Add 1 to 4. And they all finish 5. Something else with this, the standard deviation. Another trick is the sum of the deviation from the mean is 0.
Oh.
So if I take 5 away, so let's find the deviation from 4. The deviation from the mean is be negative 1. Subtract 5, negative 1. Subtract 5, negative 3. Subtract 5, 0. Subtract 5, 1. Subtract 5, 4. Add all this together. What do you got? Negative 1, negative 1, negative 2 plus negative 3 is negative 5. Positive 5. So the deviations from the mean all add up to 0. Yes, you're right. We do square them when we're trying to find the standard deviation, right? But it's interesting that if you look at all the deviations from the mean and you add them up, you get 0. Okay. Alright, so you're going to be able to use normal distribution to approximate percentage and probability. Okay, so the absolute value quiz has an average of 85 with a standard deviation of 5. The test scores follow a bell curve. What percent of students scored at least 80? Let's look at this. So a bell curve looks like this. And we said that the average is 85, which always goes in the middle. And a standard deviation is 5. Can somebody raise their hand and tell me what it means to have a standard deviation of 5? Let's hear it, Philip. Okay, you're right. It is on the other side of the 85, but what does it mean to be the standard deviation? Sarah? It's the average that it goes away from the mean. Okay? The average, if I add up all of the different deviations and average them out, that would be my standard deviation. So, like Philip said, if my standard deviation is 5, then one standard deviation away from the mean would be at 90, and one standard deviation below the mean would be 80. And 2 standard deviations away from the mean would be 95, and 2 standard deviations below the mean would be 75, and 3 standard deviations and 4 standard deviations. Okay? So today what we're going to do is we're going to learn about these percentages. Let's answer the question. What percent of students scored at least 80%? Or at least 80%? So if we were to say that, then I'm saying that the highest score is going to be 100. Can somebody tell me how many standard deviations 100 is away from the mean? That's 3 standard deviations away. Okay? And then below would be 70. So let's just say that in my class, to be a wonderful test, the lowest score is 70 and the highest score is 100, and it's normally distributed. I just told you that. Okay? Normally distributed. That would be fantastic. So what percent of students score at least 80? Philip says what? 45%? 25%? Scored more than 80? 75? Yeah, we got 5. Parents and 80. What did they say? Sydney said 86. Dina, what do you say? 60? Dina says 60. I found a post Sam. 66? 66. Okay, we're going to find out right now. So there's your, if I can remember to come back to them, there's your prediction, okay? Right? No! You can't change your answer. I want to hear what you guys think you want your answer to be. 70%? I keep it at 80. Alright. So a normal distribution, as soon as you hear somebody say it's a normal distribution, it has to have these attributes. It must be bell-shaped. Bell-shaped meaning that most of the data is all in the middle. It's symmetric, perfectly symmetric. The mean and the median are at the center, and there's a tail at each end. So that's what it means to be a normal distribution. Okay, so before we go into the bell curve and the percentages, let's look at something like this. This looks like it's pretty normally distributed, right? Is it perfectly normally distributed? No, you couldn't say this is a perfectly normal curve, correct? It's pretty normal though. Pretty close. Alright, a total of 60 female gymnasts per survey. What percent are above 60? How are you going to figure out how many are above 50? Okay. So it's actually 1 out of how many? 50 gymnasts. 60. 1 out of 50. So if you put that in a calculator, you get 0.02, which is not 0.02%, but 2%. What percent are 5 feet or taller? Figure it out. I heard it. 50%? Because 17, 7, and 1 makes 25. 25 out of 50 is 50%. What percent are between 4'6" and 5'6"? Who's here's the 4'6" and 5'6"? 46%. How'd you figure that out? How much? 33 out of 50? Is how much? About 66%? Okay, so this matches almost our normal curve. Right? And let's just pretend, you see right here, if you really look at it. This would be your mean and your median, right? And this would be within 1 standard deviation, here and here. And how much is in between 1 standard deviation? How much? 66%, and this isn't perfectly normal. So it's pretty close. So we can change If this is the middle, right? It's gonna be close to 70% right there. But it's all of this. Okay? It's not only this, but all of this. Because at least 80 means 80 or more. Alright, let's look at the actual numbers. Okay, so here's a normal curve. So if it says normal, you know for sure that these numbers work. So always with a normal curve, you know when I do these problems, I always draw my curve, I write my percents on top, and I write my numbers on the bottom. You can do it however you want, but over the years I've found that this is really good for me. So, within one standard deviation, if this is my mean, within one standard deviation of the mean is 68% of the data. So let's put the mean to it. So an IQ, an average IQ, right? An average IQ is 100. IQ score, IQ, my mean is 100, and my standard deviation is 60. So what would this number be here with this one standard deviation? On the higher end? 115. And what would be on the lower end? 85. So if you have a score of between 85 and 115, you are 68% of the population. That's 68% of the population. Let's look at a little bit more. This would be 130. This would be 70. So this one is actually 95% of the population is within 70 and 115. And I get thank you. All better? Okay. So can you figure out the rest of it? So what's the rest of it? 100%. So how much is left? 5. Right? There's 5% left over. So how much is going to be in the tails? How much have we taken up so far? 95. How much is left over? 5%. So how much is in the tail? We've got 2.5 on this tail, right? 2.5 on this tail, and 2.5 on this tail. Now that's as far as I took it last year. Let's take it one step further. This is what you'll do in statistics, big statistics. The very, very, very end tail, obviously, is going to be a very small percentage, right? So actually, the very end tails are 15 metrics of a percent. Can you guys figure out if this is 15 metrics of a percent, how much these tails are? .com. So this is 2.35. How did you guys figure that out? Subtract. So if all of the tails together are 5%, you could do it two ways. You could break it up and just say, well, this is 2.5, and I take off 0.15, I got 2.35. Or you could take 5, subtract 0.3, and then divide by 2. So that being said, could I fill out each one of these? All you need to know is this number, and then I would almost just need to memorize that number right there. You know everything. You can write the whole thing down. Right? So how much, if this is 68%, how much do you want to be? 34. Make sure I'm flat. It's not going to be 40, just in this much, just here. There's a couple different ways you can do it. Everybody at your table, figure out how much does each one of these courses right here. So all different methods you can use. Okay, what you guys come up with? 13.5. Somebody tell me how they figured out 13.5. We'll raise your hand. Okay, Tina, go ahead.
Subtracting 47.5.
You would subtract 47.5 minus what?
34.
Where did you get 47.5? So you have the whole 95. Then what do you do? You subtracted what? I can't hear you. You subtracted 68. And what do you get after you 95 minus 68? 27. And then what did you do? Divided by 2. You're just calling two different methods, right? So 95 minus 68 is 27. Right? So if I have this whole space, and then I subtract out the 68 part, it's gone. Pretend like it's gone. It starts going. If I take out the 68 from the 95, I have 27. If I split the 27, I get 13.5 to each one of these regions. But there was another way you did it, Tina, that was correct as well. I just think you weren't being able to explain it. You had 95, and then you went to 47. How'd you get there? Anybody know how you got that? Sarah. Divide 95 by 2. So if you cut 95 in half and just looked at this portion here, just this portion. That's all he was looking at. Right? So 47.5, and then he subtracted 34. I got 13.5. Anybody do it a different way? Perfect. Did you do it a different way? No? That's not surprising. Okay. Sydney, did you do it a different way? Okay, could you sit up? Alright, so let's use it. So here's our rule. Our 68, 95, 99.7. What's that 99.7 mean? Yeah, that's everything except for the last tail. So that would be within 3 standard deviations. 1, 2, 3 standard deviations. Like I said, I don't want you memorizing it. This is the part you really got to memorize for like the rest of your life. It's 68 and 95. Those two numbers. And that's what those things are important. 68 and 95. You'll see that statistics. You'll see it in papers. Right? You'll see it in places. It's a normal distribution. Like if I saw 68 and 95 and somebody asked me, is this validly distributed? I'd say, yes, it is. Because I know those two numbers, immediately. Okay? Alright. Let's do some more with this. So this says the matches and grams obtained into the United States after 1982 are normally distributed. So I hear that and I think what? 68 and 95, right? And I draw myself a curve, and I leave myself, and I immediately, so this would be the mean, this would be 68%, and this would be 95%. That's what I do. That's kind of messy. Immediately. Better. Alright, it tells me that my mean is 2.5, 0. So let me put that here. Here's my mean, which is 2.5, 0. And then my standard deviation is 0.02 or 200. There's my standard deviation. one standard deviation is going to be 2.52. And if I were to go down, one standard deviation is going to be 2.48. So how much of a population is between 2.48 and 2.52? 68%. I know that automatically because that's that much number, right? But this asks me, find the percentage of pennies that have a mass between 2.46 and 2.54. Well, 2.46 is just one more standard deviation away, because it's only 200ths of away, 200ths away from it. So here's 2.46, and here's 2.54. So let's answer my question. 95%. 95% are within two standard deviations. Standard deviations. You'll sometimes see it abbreviated like that. How are we doing? Thumbs up, thumbs down. You guys ready for your homework? Yeah. Okay, I think you're ready. Good job, guys.